Hello, Chairman, Dr. Warren, and my ears, right? And delegates, and ladies and gentlemen. It should be good afternoon now by now. So today I'm the great pleasure to present this topic on evaluation of a holistic energy benchmark, a parameter of the lift engine system. In fact, it is, in a word, this energy benchmark is in the form of joule per kilogram meter. And then, of course, the details will be presented step by step. So the agenda of the rundown of this presentation will, first of all, the introduction. To let everybody know about the little history about the lift energy performance during these 2 decades. And then secondly is how the lift energy efficiency are explained and measured in either Europe or also in Hong Kong. Because for myself, I introduced myself as Dr. Rory introduced. I'm coming from Hong Kong and explain how to measure it both in Europe and in Hong Kong. And then a little bit literature survey on the standards, mainly for the energy efficiency for the lift, which is the VDI 4707 and also the ISO 25745. And the third one is the mainly on the Hong Kong case. It is called the Building Energy Code. Fourthly, is the argument on how to assess both the lift motor drive and the traffic control efficiency than just only the motor drive, because it's quite controversial for according to the VDI and also the ISO. And then fifthly is the concept and the algorithm, how we can approach or achieve the joule per kilogram meter based on a fixed period of time. Sixth, evaluate, it is a little bit by using simulation to how to achieve this parameter. And 7, to share the result of this parameter by using a software. And do they make sense? Because at this moment, this joule per kilogram meter is still controversial. Of course, we would like to bring it out to share with you, see whether you have any feedback. And then finally is the conclusion. And of course, a little bit further works. Now this is in the center of Hong Kong, this is what we call the ICC Tower, ICC Center. The lift energy, in fact, did not receive high attention in the past due to, for sharing the energy pipe, it's only about 10% or so, or even less in Europe, because Europe normally they have less, comparatively of course, less high-rise building. In that case, the lift or the application of lift will be a little bit less than those like Taiwan or Hong Kong or whatever, because due to the tiny places over there, they need to build more high-rise building. Comparatively, with the whole energy pie chart, it will about 10%. And in comparison with those HVAC, I mean the air conditioning, it is about 45 to 50. Comparatively, it is a little bit lower. But as the time goes by and the high-rise building getting more and more, and then the consumption of energy in lift engineering will become more and more comparatively. And then building energy share in Hong Kong is about 11%, because just as everybody knows, Hong Kong is so tiny. And all the things is just in the central with those high-rise buildings. While only 3 to 8% in Europe. Of course, it depends on the lift, how it travels the distance. That means how high the building, and then there's the speed, the contract speed of that building as well. Now, in fact, a little bit basic theory or the progress of the energy applied to the lift engineering. In 1986, the Schroeder formula, who introduced the first equation to calculate the energy consumption in a building, mainly based on the square meter of that building space. I think it's rather rough in comparatively. It's rather not that scientific, shall we put it this way. And then the second gentleman is the Dulac in 1992, who also compared with the relative energy consumption with other lift only. Say, for instance, the electric lift, we have the AC2, that means two-step lift, the old one, and then up to the most modern one is the AC VVVF or the DC VVVF, who try to compare those and then make somewhat like another benchmark. In comparison with my topic today is another matter. And then in 1996, I think he's in, yeah. So Mr. O'Salif, who compared the lift energy consumption of various types of motor drive and introduced the concept of putting the lift regenerative power back to the power grid. It's quite, it's quite uncommon nowadays. In particular, in Hong Kong, we normally push the designer to go on this way, to try to design those lifts with regeneration power. And also, we have the consent or the compromise with the utility companies that we can put on those generated or regenerated power back to the electricity grid to save money in order. And then this paper highlights the energy efficiency of the lift based on the Hong Kong case, the Building Energy Code of Hong Kong. In fact, it is quite new. It's only launched or come to an advance last year. And it's paired technical guideline, which has been done in 2012, the guidelines. And then this photo, in fact, I just want to show, we just not only totally rely on the energy efficiency of the motor, but rather we would like to pay more attention into the control system. Now, it aims to provide an overall benchmark. It is the main title for this paper, the presentation, to see whether we can achieve the joule per kilogram meter that can cover all drives and also the control of all kinds, including the olden lift, the AC two-step lift, and to the nowadays the permanent magnet, synchronous motor, or even the linear motor. I've learned last year in the same situation that the linear motor has been developed quite mature for those can in the two-dimensional, traveling in two-dimensional. It's quite interesting and ingenious, and also the hydraulic lift. And then if this joule per kilogram per meter is successful, and then we can apply this benchmark in all this kind of lift. Now, another literature survey, we compared three standards. The first one is the VDI 4707, which is initiated in Germany in 2007. And they also, similar like those energy labeling, they divide the energy consumed by the lift in 7 categories, from A to G. The best will be, of course, the A grade, right? The worst is the G grade. And then I mentioned about this. And then the VDI measures the lift when they only travel and at the standby mode. And while at our Hong Kong case, we normally just on the other way around to measure those lift in operation rather. And also the rated speed, rated load, and the travel height, and it's quite normal. As quoted in the VDI guidelines, when the lift is nominal demand, whenever it can reach to 4,000 something kilowatt per year or even lower, that means they can get the grade A energy label. I just obtained it through the source of the energy guideline. Another page of the literature survey will introduce the ISO to 25745 and 1 something. And then it emphasizes an empty car is repeatedly cycled. That means from home level to the top or the rooftop of the building. And then the current cycle, see whether how many energy consumed for this very referencing or representing figures, just a round trip based on how high the building. And then the first, I've talked about this. And then second is to consume the predetermined landing. That means in this issue, it will not just limit it to the home level and the roof level, but rather you can predetermine two, say for instance, from the second floor to seventh floor. So only these 5 stories. And then you can put on another energy referencing figures. We term it as the SC, means cycling, rather short in comparison with those high-rise, and then it is called the referencing cycle. And these 2 cycles will, of course, introduce the energy. And so the average of this constraint energy in comparison with the short cycle energy will come to an equation with this energy minus this energy divided by the distance travel for the whole building and the predetermined distance of this one, and then divided by 2. And then that will be come out with a mean, the energy referencing mean. And then it's the main spirit of the ISO 2000 something. In fact, in the Hong Kong, the BEC, I mean the Building Energy Code, we are, the blueprint, we are copying from this concept. Of course, we modify more. I'll come to the third one. Go back to our Hong Kong case. And then last year, in fact, we have done this BEC for more than a decade, more than 10 years. But last year, we modified it to become more up-to-date with those references from internationally. The Live Energy Code is closely related, as I've said before. And then reference value are given in the inside this BEC, there's quite a lot of tables for those building service engineer or lift engineer to save the time to calculate from the scratch. Rather, they just simple to find out those figures related to the building, the height of the building, and the contract speed, and then the capacity of the car, and then they can just simply choose those right answer out from this table, and that's it. And that's the reason why I call it act as a design handbook rather. Now this is, in fact, it is free of charge. Every one of you can download it through the EMS. EMSD means the Electrical Mechanical Services Department under the Hong Kong, nowadays called the Works Bureau. And then it's free of charge once you go into the website, and then you just in the left-hand side, you find out the put-down menu of the publication, and then you try to use the search engine. You can find it out, and then you can freely print it out. It's quite thick. It's more than 200 pages, free of charge. Now go to the main theme of this presentation. Why the reason? Why we propose to find out these benchmarking parameters. Now, so far we have talked about the VDI and also the ISO, right? So those are related to the Europe or UK in this way. And then now we have another benchmark called joule per kilogram meter. And in fact, we have. Now, the first, this one is a little bit saying that this VDI and ISO is a little bit simply by guess. If you believe or not, it's a little bit by guess, not measured at real time. So there's rather not unscientific, but in comparison, I prefer to go to more detail by using simulation rather, right? So whereas the Hong Kong Building Energy Code measures one full load upstream. This is another drawback or the discrepancy of this measure. It's only do some example or do some experiment by using upload only. How about the download? How about in the idle? Or how about in a very short period? Or this kind of thing. This little book didn't do that at all up to the present moment. And one of the co-authors of this paper, Dr. Abersole et al. At 2005 has raised out this problem saying that there's less contribution to the reality. But rather, he also believed that the contribution of the supervisory control or the car dispatching. In fact, in one of the software I've chosen in this research, I've used the dispatcher. That means the supervisory control. It's not included in either the Hong Kong case or also in the European case. These three kind of standards, they didn't include this supervisory control. Something like this one. And also I find it from the exhibition outside, they have got a very scientific one. I would like to contact those gentlemen to know what about this. And what's the joule per kilogram meter? And then now, this in fact has amalgamated three dimensions. One is the joule, is the energy, while the kilogram is the weight, and then the m is the meter, the distance. That means we will surround these three kinds of dimensions. It is the average energy to transport 1 unit of mass, no matter if it's a human being or the goods or whatever, and then either the either the passenger or goods and go up or go down 1 meter up or down, and then within an agreeable period of time, and then they will do the calculation from that. Now, that means these three I mentioned before. And then the J parameter has been included in the technical guide since 2012 from the EMSD of the Hong Kong government, but not in details. In fact, they haven't done any, but just simply copy the idea from Dr. So. Dr. So at that time was one of the advisory member, and then the government just simply adopted the concept from Dr. So, and then that's it. And then Dr. So was a little bit complaining about why the government did not follow his suggestion and do all this kind of simulation, rather just simply to print out this guideline. Of course, this technical guideline is not only for lift. They include air conditioning, electrical, and everything. No pumping and drainage, sorry. But because in Hong Kong, pumping and drainage that's not inside the scope of E&M or building service or whatever. They belong to the architectural stuff. And then so far, again, to continue, that within a period of times, now this just for example only, from 0 to t or whatever, we just, normally we can skip it due to the shortage of time. And then, but during these 2 hours, say for instance, there must be so many stops in between. There may be so many stops, because once you go into the car and then you can push the call button, the call button to stop at the floor that you want to go out. And then, in fact, this can be found from any lift books. It is called the brick-to-brick journey. And then in the software, it also they have the spatial plot. The spatial plot, it looks like a tower with so many stops in between. Now, eventually, 1 joule per kilogram meter value can be formed for each this time period. Now, you can imagine the cave time. That means you can divide the period of time into so many slots, SLOT slots, right? You just divide it into. And then finally, we come up with this figure, this equation. The energy during this time, and with so many K slots, and then divided by the small weight and the small distance being troubled, and then just simply summing up together, and then do the division, and then you can get this one. And due to the time is short, I will go a little bit faster. Now, in fact, everybody knows this one is what kind of software, but due to I don't want to have any advertising effect involved in this seminar, and then I just will not mention about what is the name of this software. Everybody knows, very famous. And then the beauty of this recently upgraded software is that it can do the energy part. Without this part, I don't think this simulation can be done whatsoever, which is very true. Yeah, due to the advantage of this software, and then it triggered the doctor's way in my mind to do this simulation. And also that will be included in my PhD research as well. Yeah, the energy simulated through the software is only at so and so, and I don't think we need to go into details. And then this one of the screen. And this paper, the main concern is to use different lift data scenario to run the J parameter. In fact, we just want to get more involved of those uncommon, or put it this way, abnormal, put it this way. Because if those, of course, first of all, we must do the parameter within the normality, say for instance, for those office building, for those residential building. But how about those hospitals? How about those institutional buildings like the universities? And then somehow the teachers or the students will just simply run within the floors rather than go down to the home or go up to the roof. But it's just to wandering around within the cell floors within the same building. And then the software generated the raw data. Now, in fact, this software can only generate its own language. And if I would like to put it into a more useful manner, and then I need to transform this language into the Excel spreadsheet. In fact, they have get the command to change from the CVS to, in this case, what we call the ELVX, and then I can translate to the XLX. This is one of the generated result within the time zone. And then based on this flow, in fact, I skipped a little bit about how did I come into these figures. And then it is within the 4-hour fixed time. And then from table 2, see whether I can show the table 2. The table 2 is the moving time slot. Now you can see it is time slot for every 15 minutes we have a move. And then within 2 hours there will be about 8 plus 1, that means about line location. And once I put this line time slot into the simulation program, and then it will generate all this kind of thing into. And then finally, now the sum of this and also this will not give any joule per kilogram meter, but rather I use the Excel and then put on a formula. In fact, the model itself inside the software is what we call the energy model. It is based on 2 linear equations. And then I just simply by using this 2 linear equation to change a little bit and then to multiply, and then we'll get this result. And then you can, just before I close this slide, and then you can see the J value or the J kilogram meter is quite constant overall, 47 something and 42. That means the input of the software itself and also my self spreadsheet is in the successful. It approaching successfully. This is one of the calculation examples of this. And then it's one of the curve due to that 9 points. This 1, 2, 3, 4, 9, and then you can see, in fact, from this time zone, we can represent in the morning session from 8 or to 9. Everybody rushed back to the office to commence their daily work. And then in the middle, about 10 something, the tea time, or as what I'm saying, then they will just run through the interfloor by themselves. Because some office building, some law firm, and some sort of institutional, like the university, they have their own classroom in the middle of the building. And then within which, and then they all just fooling around. So you can see the lift usage is normally in the middle at about 10 o'clock, and then it's quite steady, while they decline down, approaching 11 or 12 when the people are going to have lunch. And you can see the down. That means in comparison with this joule per kilogram meter, and then that means they will use less energy when they use the downpeak option in comparison with the uppeak low. And then normally in the daytime, you use about 60 rather than the 40 something as I've showed you before. So and I know that. So conclusion, just so sorry to keep it. In fact, this is what I'm saying. What I'm saying in words. And then the breaking power. Further work, I think is quite interesting, and then I would like to show you. The authors, including Dr. So and Professor Stefan and myself, would do more different scenarios, simulation and input more strength. Now, I emphasize the strength. That means I would like to do those abnormal ones rather than do just normal. It doesn't make any difference. But if I find this strength condition is also different job data into the software in order to obtain more irregularities based on this parameter. And this kind of parameter value, more confident we can use. Or in fact, we will rely on it. And it will be more beneficial to those live industry, building service engineers, and the public management and the other stakeholders. And then finally, the argument whether we use the watt-hour, meter-watt-hour from European side or the word second from Hong Kong, we need to find out the balance. But in fact, the European side and the Hong Kong side are obeying different concepts. So we cannot do any like-to-like comparison. I think that's all for my presentation today. Thank you.